Hello everyone, in this video we will discuss why lithium behave differently from rest of its group member, and this property is known as the anomalous behavior of lithium. That is why lithium behave differently from rest of its member. And this is the property which is shown by every first member of S and P block. That is, for example, in the first group lithium is showing the anomalous behavior, in the second group beryllium is showing the anomalous behavior, in the 17th group we can say fluorine is showing the anomalous behavior. So all the first member of group behave differently from the rest of its member. And reason behind this is, first point is small size of lithium and lithium plus ion. In all the group members, as we know, down the group size increases. So lithium possesses the smallest size and has high ionization enthalpy. And due to this, they have high polarizing power. Now, what happened due to this polarizing power? Generally, the salts of alkali metals are ionic in nature. Now, just for example, NaCl is an ionic compound. But due to high polarizing power of the lithium compounds are, or halides of lithium are mainly covalent. Now let's discuss how this happens. So size of lithium is very small, due to which it possesses the high charge. So when it placed in contact with an anion, then because of its high charge, it polarized the anion. So this is the anion which is initially non-polarized, but when this high charge is kept in contact with this anion, then it attract the negative cloud towards itself. तो आयनिक कैसे बनता है? बाय लॉस और गेन से बनता है, बट कोवलेंट नेचर है, विच मीन्स इट इज शेयरिंग. तो जो पहले कंप्लीटली लूज हो चुका था उसको ये थोड़ा अपनी तरफ अट्रैक्ट कर लेता है, which means there is now a covalent character in this bond. So because lithium has small size, high charge, due to which it has high polarization power. Polarization power means when it is kept in contact with a negative ion, it attracts the electron cloud towards itself. That is, it introduces the covalent character in it. So we can say this distortion of electron cloud of an anion is known as polarization, which is done by a high charge cation, small size and high charge cation, due to which the ionic bond acquires some covalent character. So in case of lithium halide, particularly lithium iodide, have maximum covalent character. Reason: size of lithium is very small, have high polarizing power. Size of anion is very large, it can easily distort its electron cloud in the presence of this lithium ion. And hence lithium iodide is covalent in nature. And the last but the important point, that is the non-availability of d electrons, or we can say absence of d orbital. Now in each case, whether it is alkali, alkaline or any group, all first members do not possess the d orbital, because वो उनमें second shell ही present है, 2s and 2p. So because of absence of d orbitals or the d electrons, many properties are not shown by them, which is generally shown by other group members. Lithium is hard, while other can easily cut by knife, just like sodium and potassium. Next, lithium react with water slowly, but others react violently and even catches fire. And lithium hydroxide is a weak base and sparingly soluble in water, whereas other members, just for example NaOH and KOH, they are the strong base and they are alkalis because they are completely soluble in water. On heating, lithium hydroxide easily decompose into lithium oxide and water, whereas other hydroxides fail to decompose even on strong heating. Similarly, lithium carbonate easily decompose into lithium oxide and carbon dioxide, whereas carbonates of alkali metals are quite stable to heat. And lithium is the only alkali metal which reacts with nitrogen and form the lithium nitride. So in the end we can say that lithium is differ from rest of the alkali metals in most of its characteristics, but it is part of the group because of its electronic configuration. But for a fact it resembles magnesium, that is the second member of the alkaline earth metal, as it is present diagonally to magnesium. So that type of relationship is known as a diagonal relationship. Maximum properties are similar to that of magnesium, and because of this similar properties, the relationship between the lithium and magnesium is known as a diagonal relationship.